Okay, good. Welcome back to Sundays at 2. We've got a good crowd here. Glad everybody's here today. We've got a great session for you here, and so we're looking forward to moving ahead with that. By the way, if you have one of these, please make sure it's off, if you could. The typical thing, so if you do that, I would appreciate it. So I have the pleasure of introducing our speaker for today, Jeff Chester, right here. And let me tell you a little bit about Jeff before we get started. Jeff is the Public Affairs Officer and Historian for the United States Naval Observatory in Washington, D.C., a position he has held since 1997. Prior to joining the observatory staff, he spent 19 years working in the Albert Einstein Planetarium at the Smithsonian Institution's National Space Museum as staff astronomer, photographer, and visual production coordinator. He has always had a keen interest in astronomy and has been actively observing the sky for more than 50 years. He is a member of the Association of Lunar and Planetary Observers, the International Dark Sky Association, and the Northern Virginia Astronomy Club. So we're very fortunate to have Jeff here today. And so without taking any more time, Jeff.
Thank you very much. All right, can everybody hear me? Okay, that's good. Pardon me if I tend to wander off a little bit today. I have spent the last 2 nights out with my telescope until about 2 o'clock in the morning, taking pictures of the sky because that's what I come down here for, apart from the hospitality of our hosts as well. But this is a great place for those of you who like to look at the sky. It is something that almost every time I come down here, I come away with images that are just something I can't get anywhere else. And so I'd like to share some of those with you today. It's a really unique little location that you have out here in terms of the access to dark skies. And so I want to present some images today that may be indicative of may inspire you to pay a little bit more attention to the beauty of the sky, as well as present some ideas on what we can all do as a community to preserve that. So that's going to be the subject of my program today. So, now, most of us, when we go on vacation, we like to take pictures to show that we've been someplace. Okay, so that is yours truly, a long time ago, unfortunately, but you can look at this picture and you can tell pretty obviously where I was. And that's all well and good, but it's not really the kind of pictures that I like to take. Obviously, I didn't take this one. What I really like is to have pictures that have the sky and water. So that is that's a picture that is more important to me of my trip to Egypt than seeing of course I love seeing all the monuments and everything as well, but this is the kind of thing that I look for when I'm going to places like that. So pretty much everywhere I go, I try to find interesting images to take or interesting things to photograph that are indicative of the place that I've traveled to. So this is a couple of years ago, I was out near Tucson in Arizona. And this was taken from Blackwater Falls State Park out in West Virginia. You never really know what you're going to get when you get a sunset or clouds in the sky. The lighting is always constantly changing and constantly presenting you with new things to image. Even from near where I live in Alexandria, you can get some fascinating things to see in the sky.
Your entrance said how to keep the sky.
I'll get to that. Okay. I'm getting to that. All right. So the sky has moments of beauty and serenity, like this, and it also sometimes has moments of anger, like this. And sometimes you get a little bit of both. So that brings me down here to the northern neck. One of the things that I constantly find is that the sky here is always changing. It's never the same twice, and it always presents, every time I visit, a new aspect that I had never seen before and that I want to try to preserve. So I like to spend a lot of time taking pictures of the sky in the daytime, but I also like to take pictures of the sky at night. And sometimes even in between. So, I don't know how many of you grew up in the 60s. Well, a lot of you probably grew up in the 60s. I'm a big fan of the Moody Blues. And whenever I see a sunset, this refrain from Days of Future Past goes through my mind. Oop, getting ahead of myself here. Don't want to skip too many of them. So, sunset is a magical time every day. I have never seen a bad sunset down here. I don't know what you would define as a bad sunset, but compared to what I have up in Alexandria, every time the sun sets here and it's not overcast, there is always something really wonderful to see. And so this is, I'm going to go through a few of these images now, just to give you an idea of what these sunsets are like. This was actually taken this past Friday evening. So as I say, every time I come down here, I see something good. This is one of my favorites. We have a very interesting phenomenon here, which are called Crepuscular Rays. Whoa, go back there for a second. These are crepuscular rays. The sun is just below the horizon, but it's casting light off the tops of these clouds. Try that again. It's not supposed to do that, but technology. This is just a wonderful aspect of the sky that most of us probably never really appreciate. And then this is one of my favorites. I captured this one a couple of years ago. We have here, let's go back. So what we have here is the very young crescent moon, which is down here. Not supposed to do that. But anyway, there's the very young crescent moon right here. The planets Venus, Jupiter, and Mars up here in the evening twilight. It pays to have good horizons. And of course, as twilight fades, the night begins to reveal its secrets. Sometimes we have this bright thing in the sky, which can add a bit of natural light pollution, but it has another interesting advantage in that it lights up the landscape with a very soft glow. And then the stars come out. So if you have been paying attention in your planetarium, I don't know if there is one around here, but if you've ever visited one and you remember, there is the Constellation of Orion. And here's Orion's faithful dog, Canis Major, with the bright star Sirius, the dog star, following along behind. Anybody recognize this group up here? The Great Bear or the Big Dipper? That's right. This is just taken with a camera stuck on a tripod in Chad's driveway. You never know when or where you're going to find an interesting image to take. It's also taken under the light of a fairly bright moon, which is why everything here appears almost as if it were in daylight down in here. The moon actually is a reflector of sunlight. Now, it doesn't reflect that much sunlight. If you were to hold a piece of lunar soil or a good lunar rock in your hands, which I actually had a chance to do working at the Air and Space Museum, it has about the reflectivity of a charcoal briquette. We all think the moon is very bright, but it's really very dark. But it sheds enough light so that we can get a little bit of light in the evening, and that's one way that we can get around at night here without having to worry about artificial lighting. Just go out when the moon's out. And another picture of Orion. I never get tired of taking pictures of Orion. Again, here's Orion. Backwards, please. There we are. So here's the three belt stars, the red star Betelgeuse, the bright star Sirius over here. And right here is a very interesting little formation. It's called the Sword of Orion. I can't see that from Alexandria at all. But down here, it's very easy to see. And if you look at the middle star in the sword right here, you see it's got a little fuzz around it. Take a pair of binoculars out and look at that sometime. You've got a couple more weeks before Orion gets too low. And you will see what is known as the Great Nebula in Orion. And I have a picture of that through the telescope that we'll see in a few minutes. This is one of my favorite shots. This was taken a few years ago. This is, I did it again. This is the planet Jupiter. And here you can see the core of the Milky Way galaxy. There is an asterism here. This is the constellation of Sagittarius the Archer. It's an asterism that we commonly call the Teapot. There's the top of the pot, here's the handle, and here's the spout, and we know it's the spout because that's where all the steam is coming out. Now, when you look at this part of the sky, the ancients would like you to believe that you were looking at the figure of a half-man, half-horse shooting a bow and arrow. I tend to think that the ancients suffered from a certain amount of rye poisoning when they looked at the sky. A teapot is something which is, at least for me, far easier to recognize. Another constellation that we have over here is the constellation of Scorpius, the Scorpion. Here's the head of the Scorpion over here. Here is the star Antares, its red heart. And then the tail dips down here below the horizon, ending in these two stars down here, which are called the Stinger. This is a summertime constellation. It is a wonderful sight looking out across the Rappahannock River to see. The only problem that we have is that this down here, that's Urbana. Sorry folks if you live in Urbana, but you are kind of spoiling some of my pictures, but you know, I can still deal with it. So here's another shot of the Milky Way. This was taken a couple of years later, so Jupiter is now over here instead of over here. Here's Scorpius again, and again another shot of the Milky Way. One of the things that is really, really fun with the Milky Way is you don't need a big telescope to really enjoy some of the sights that are out here. If you have a good pair of binoculars, all you need is binoculars in a dark sky. So here we have a star cluster. This is called Ptolemy's cluster. Up here we have what's called the Sagittarius star cloud. This is an area that's called the Lagoon Nebula. All of these are easily visible in binoculars, and one of the things that's amazing is when you look especially at these fuzzy parts of the Milky Way here, they begin to resolve into an incredibly huge number of stars. And if you ever want to feel like you are a very small part of a very big universe, your binoculars are good enough to show you that. Every now and again we get visitors that come and go, catch us by surprise. A few years ago we had a bright comet in the sky that went by the rather prosaic name of Comet Pan-STARRS. It used to be 20, 30 years ago that most bright comets were discovered by amateur astronomers who would dedicate their evenings to sweeping the sky looking for fuzzy blobs of light that weren't supposed to be there. But starting in 1994, after a comet named Shoemaker-Levy 9 crashed into Jupiter and basically caused features in Jupiter's atmosphere that were visible with amateur telescopes from the Earth, people suddenly woke up to the idea that there are things out there that can hit us. And so they began deploying large arrays of telescopes, automated telescopes around the world to look for potential things that can hit us. And most comet discoveries are now made by those. So if you come across a comet that has a really strange name, it's actually named after the instrument that discovered it and not the person, which is too bad, but you know, I'm going to miss my claim to fame on that one. But here it is in the sky, quite visible, and this is a very good impression of what the naked eye saw when that comet was visible in the sky. So now we're going to move a little bit further out. As I mentioned, binoculars are a great way to see things in the sky. But one of the things that I like to do is take photographs of things in the sky with a little bit more detail than what you can get with binoculars. And I kind of think of these as souvenirs in many ways of not only places where I have taken the images, but also souvenirs of places that I have visited vicariously through the telescope. So you've probably heard of an old product that was called Janitor in a Drum. Remember that? This is observatory in a trunk. Because I live in a major metropolitan area, I really can't do a lot of good imaging of the sky from my front yard. I have two 200-watt street lamps that cast a beautiful orange glow over my front lawn. So it is important for me to be able to have something that I can pack up and take somewhere. And my main criterion for putting this together was, at the time that I put this system together, my transportation was a Mini Cooper. So you got to be able to fit telescope. So my criterion for purchasing a car is it's got to be big enough to carry a telescope. The rest, you know, not really too much about that. But this folds down and it's transportable in a couple of shoulder bags. And it is really a wonderful way to capture some of the things that we see in the sky. So I'm going to walk you through some of the more spectacular ones that I've culled from my collection over the years. This one is probably one of my favorites. Incredibly photogenic. It is known as the double cluster in the constellation of Perseus. If you go out with, you know, a lot of people have your little phone apps here with your, anybody have the little star map thing on your phone? Yeah, so if you go to that and you put in find double cluster, you do it in the fall because that's when it's best seen, but it will point you to the point in the sky where this is located. It's in the Milky Way between the constellations of Cassiopeia and Perseus. This is a pair of what we call galactic star clusters. So all the bright stars that you see in there are stars that are in this cluster. All the other stars that you see fading into the background are stars that are more distant in the Milky Way. And that gives you an idea of what the Milky Way is made up of. The stars that make up the brightest stars in these two clusters are some of the most intrinsically bright stars we know of in the universe. We tend to think of our sun as, you know, it's a pretty bright star. We feel its light, we feel its heat. But our sun is an extremely, what we would call garden variety star. There's billions like it throughout the Milky Way galaxy. The brightest stars that you see in this cluster are so far away that in order to appear as bright as they do in these images, or as bright as they do visually through a telescope, they have to have a very, very large intrinsic brightness. So some of these stars, the brighter ones that you see, have an intrinsic brightness on the order of 200,000 times the brightness of our sun. So it's a good thing they're way out there. Otherwise, if they were as close, say, as the star Sirius that we looked at a little earlier, we would not know what night is. And that would not be a good thing if you were an astronomer. Here's another group of clusters in another part of the Milky Way. This is another one of my favorite star fields. These clusters are known as, this is Messier 47 and Messier 48. This one here, I can't remember the number of it. It's in the New General Star Catalog, as is this one up here. This is a spectacular field of view in binoculars. This is located in the constellation of Puppis, which is a constellation that nobody's ever heard of. But it actually is just to the east or left of Sirius and the stars of Canis Major. These clusters, again, are located at a distance of several thousand light years. Now, we were talking at lunch today about distances in space. When we look out into space, we are not only looking at objects that are far away, but we are looking back in time. And this is a concept that I still have difficulty sometimes getting a grip on. But when we look at the moon, we see it as it was 1¼ seconds ago, because that's how long it takes light to get from the surface of the moon to here. When we see the sun as it was 8 minutes ago. When we see the planet Jupiter, we see Jupiter as it was 45 minutes ago. When we see Saturn as it was about 75 minutes ago. When we see Pluto, which you need a big telescope to see, but nonetheless you can see it, we're seeing it as it was about 5 hours ago. And that's kind of the boundary of the solar system. The next big leap is out to the nearest stars. The nearest star to us is a star called Alpha Centauri. And we see that star as it was 4.5 years ago. That bright star Sirius, we see that as it was 8.5 years ago. And when we look at these clusters, we are seeing light that has taken 2,000 years or more to get here. Now, these are some of my favorite objects, because when you point even a modest telescope at them, they actually look like this picture. These are called globular star clusters, and we're starting to get into a season where these are becoming prominent in our sky. This is one that's called Messier 13, which is a globular cluster in the constellation of Hercules, northern constellation. It is located just to the west of the bright star Vega in the summertime sky. This is a cluster of about 500,000 stars, and it's located about 25,000 light years away from us. If we were on a hypothetical planet that was inside this thing here, the average distance between stars would be measured on the order of 1/4 to 1/2 a light year. And we would definitely not know what night is, because the sky would be full of stars that were, when you put all their light together, would have a combined effect of the light of the sun. So I'm glad I don't live here. I like looking at them from afar. And when you look at these images, you'll find every now and again there are strangers that kind of work their way in here. So you may see there's this little fuzzy blob down here. And here's this little fuzzy blob down here. Those are external galaxies. So while this cluster is 25,000 light years away, this galaxy is about 100 million light years away. And this one here, that little guy right there, is about 300 million. So the light from that little galaxy started its journey towards us before dinosaurs existed. Pretty cool, huh? This is another globular cluster. This one is located in the constellation of Scorpius. It's very easy to find. This is the bright red star Antares. Whoops, I almost hit the wrong button there. This is the bright red star Antares right here, which is actually surrounded by a dust cloud of material. And this is a star that is just west of Antares. There's Antares, this star, and there's another one down here, visible with the naked eye. Look with your binoculars and you will see a fuzzy blob between in this little triangle here. Very easy object to identify with binoculars, and a small telescope will begin to show individual stars as you see here. This one is called Messier 4. And again, there's an interloper. This is a little globular cluster up here, a little further away. These things are all over the summertime sky. This is something that's called the Trifid Nebula. This is one of those things that you will find in just about every astronomy textbook. This is a gaseous cloud, actually a couple of clouds of gas. The red color that you see is because there is a very hot, energetic star right here, which gives off most of its radiation in the ultraviolet part of the spectrum. And that ultraviolet radiation excites hydrogen gas around it to glow with a characteristic red color. So it's almost like gas glowing on a fluorescent tube. This blue stuff that you see up here is what's called a reflection nebula. It's far enough away from the star that it's not it's not being stimulated by the ultraviolet radiation. Instead, it's dust grains that are reflecting the blue color of the star. Again, these are kind of littered all throughout the summertime Milky Way. Now this is one of my favorites. This is an object which is called the Dumbbell Nebula. The reason it's called the Dumbbell Nebula is that in a small telescope, you don't see these faint extinctions here, but you do see something here that looks kind of like a bow tie or a dumbbell, which I need to be using more of these days. This is what happens when a star like the sun eventually reaches the end of the line. So this is what we're going to look like in about 4 billion years. And that's a billion with a B, so don't worry. It's not going to happen anytime soon. The sun will eventually exhaust all of the hydrogen fuel in its core. It will ultimately collapse into what is called a blue dwarf. And it will be very massive. It will emit a lot of light in the ultraviolet radiation, and all of the material that has been sloughed off as the star collapsed will form a shell around it, and that hot star in the center will emit ultraviolet radiation and cause this particular color to glow. Now, this color, this bluish color, is very characteristic of these objects. That is caused by what we call a spectral line of doubly ionized oxygen, which can't be reproduced in any laboratory on the Earth because there is no place that we can pull a vacuum that is as strong as the vacuum in space. So you will only find objects of this type out in deep space. There's the Orion Nebula. We talked about that a little earlier. This is what you see in the center of the sword of Orion. One of the things about this is that we have some interlopers in here as well. So you probably noticed this streak up here, and there's a streak down there. Those are actually the trails of geostationary communication satellites. These are satellites which orbit the Earth at an altitude of about 22,300 miles. They put them out there because that way they take one trip around the Earth in the exact same time it takes the Earth to go once around on its axis. So they appear over the same geographic spot, and that's what your satellite TV dish is pointed at. It's one of these. Now, the reason it leaves a streak here is that if I were to turn off the guiding motor that moves the telescope with the stars, all the stars would trail out, but the geostationary satellite would be a fixed point because it stays in the same place relative to the Earth. But in order to photograph something like this, I need to be able to move my telescope with the rotation of the Earth so that I can keep the telescope on the object that I'm photographing. Geostationary satellites are something of a bane to astrophotographers because they are far enough away that for a good part of the year they are always visible in the sky. And now there are more and more satellites being launched into low Earth orbit. Don't get me started on those, but anyway, they are also some, but at least we can wait those out because usually after about 2 hours after sunset, they're not lit anymore and we can't see them.
What's the exposure time?
These are cumulative exposures anywhere from half an hour to an hour and a half. But thanks to the modern miracle of digital photography, instead of taking one exposure for an hour and hoping that my guide star doesn't get lost or anything like that, I actually will take a series of 23-minute exposures, and then using software I can register the images and digitally co-add them together and effectively get a 1 hour exposure. Digital is great, I'll tell you.
I'll be throwing you a curveball. Have you heard recently on the news the discovery of Earth-like planet number 9, they're calling it?
There are probably hundreds of Earth-like planets out there back when I was in school as a physics major back in the early 70s, the number of planets that were known were 9 in all the universe. And then in 2006, they demoted Pluto, so there were 8. But shortly after that, and really around that time, they began discovering planets orbiting other stars. So they launched a mission dedicated to look at a certain patch of sky and look at the stars in that patch of sky and monitor them continuously for a period of 10 years. And by doing this, they could measure very small fluctuations in the brightness of stars as their planets transited in front of them. This was a mission that was called Kepler. Kepler discovered several thousand planets around stars outside of the solar system. And now there's thousands more because there are more and more surveys that are locating these things. And by analyzing the light, without actually seeing the planet itself, they can analyze the light, the time it takes the object to transit in front of the sun, or the star, how much light it dims from the star, and so on. They can determine its orbital characteristics and its approximate size and mass. Really, really interesting stuff. Well, you may have heard that about a month ago they launched what is now known as the James Webb Space Telescope. They have recently started getting some of the first engineering images back from it. Unlike its predecessor, the Hubble Space Telescope, this one is in focus. And the first pictures that have come back are absolutely stunning. They are engineering images, so they're not pretty, but the details that they show mean that we will actually be able to image Earth-like planets around nearby stars. So I can't wait for that to happen. So no, it's not a curveball. This is an object which is called the Rosette Nebula. I think it's very aptly named. This is actually located in a part of the sky that is just to the east of Orion. It's a very dense Milky Way star field. It is in a very obscure constellation called Monoceros, the unicorn. Now, personally, I've never seen a unicorn on the ground, and I still have trouble finding a unicorn in space. But willy-nilly, this object is in there. This is a cloud of glowing gas and dust that surrounds the central star cluster. Once again, these are very hot, young, energetic stars, and they have actually blown out a cavity in the center of this thing. It's kind of a spherical void, and what you're looking at out here is a glowing spherical shell around this cluster of stars. The apparent size of this object is about the size of the full moon, so it's pretty big. So you don't need a big telescope to get a good image of it. This is one that I took Friday night from right here in beautiful downtown metropolitan Mollusk. This is one of the first objects that I tried to photograph when I began getting into astrophotography, and whenever I have an opportunity to take a picture of it, I go for it again. And I'm gradually getting better at it. This is an object which is called the Horsehead Nebula. And I think you can see why. There is, whoops, back here. Jump ahead of me there. There we go. So, kind of looks like a knight on a chessboard. This bright star up here is a star called Alitok. This is the left-hand star in the Belt of Orion. So this actually should be rotated like that, but in space there is no up and down, and I wanted to fit it on the screen. So north is actually up over here. This is an amazingly complex region of stuff in the sky. The whole of Orion is basically a gigantic star factory centered on the Orion Nebula. This is a nebulosity that is associated with that, but it's well away from it. One of the things to notice here is look at how many faint stars there are over here, and then look at how many faint stars there are over here. There's quite a difference. And the reason for that is that this is a little protrusion of what is called a dark nebula. Now you've heard of dark matter, probably. That's dark matter. It is gas and dust that is not lit by anything. It doesn't have enough heat or energy inside to create its own light. Instead, it obscures light of objects that are further behind it. This is the stuff that stars and planets and people and everything else that we experience in our day-to-day lives, that's what we looked like 4.5 billion years ago. This is the stuff that builds stars and planets. There is enough of this dark stuff in this image to make about 10,000 stars and associated debris the size of the sun. So this is where future solar systems will be created. Really, really amazing part of the sky. So this is the most distant object you can see with the unaided eye. This is the Great Galaxy in the constellation of Andromeda. There is a large asterism that we see in the fall that's called the Square of Pegasus. You go to the upper right-hand corner of the upper left-hand corner. This is my left, this is my right. Upper left-hand corner of Pegasus, and there's a bright star there called Alpheratz. And if you look to the east of that, to the left essentially, you'll see two diverging chains of stars. And if you go out to the second star in that chain and then hop up 2 stars, you will see what looks like a little detached portion of the Milky Way with your unaided eye. A little fuzzy patch of light. You look at it with binoculars and all of a sudden it is a much larger patch of light, but it has a very interesting, very amorphous glow. There's nothing quite like it that you see anywhere else on the Earth. There's no point source or anything like that. This is the nearest galaxy to the Milky Way, the nearest large galaxy to the Milky Way. So what you are looking at here is the combined light of about 200 billion stars. And the distance to this is about 2.5 million light years. So when you are looking at the light from this object, you are looking at light that started its journey towards us before we existed as a species on the planet. So you are literally looking back through the entirety of human history when you see this in the sky. It has a couple of little satellite galaxies around it here, but again, something that is very easy to see, especially from down in this area. Here's another one that I took Friday night. This is another galaxy. This is in the constellation of Ursa Major, the Great Bear. It's actually located just off the handle of the Big Dipper. This is called the Pinwheel Galaxy. Again, a galaxy that's like the Andromeda Galaxy, but in this case we are looking at it kind of face on. This particular galaxy is located at a distance of about 12 million light years. Here's another pair of galaxies that are also located up in Ursa Major. This one is called Bode's Nebula, named after the astronomer who first discovered it. And this one here is known as the Cigar Galaxy. These are both located, again, about 10 million light years away from us. This is a fairly normal spiral galaxy, fairly tightly wound. This one here, though, is a very interesting one. You'll notice that it doesn't have any real structure to it. It's got some, spots where there's dark matter and everything in there. There's something going on in the center of that galaxy, probably a supermassive black hole, that is causing that to distort into a very odd shape. So we can learn a lot just by looking at pictures of galaxies about their structure, their morphology, and their evolution. Here's one that I took last night. That's why I'm a little bleary-eyed today. These are 3 galaxies in the constellation of Leo of Orion. This is an edge-on galaxy here. This is what the Milky Way would look like if we were to see it edge-on. If you go out at night, especially in the summertime, and look at the Milky Way, you'll see that there's a dark belt that kind of bisects the Milky Way. That's what we're looking at here. And that dark material, once again, is the stuff that stars are formed from. And there's 2 other fairly bright galaxies nearby, and once again, if you look very carefully in this, you'll see all kinds of little fuzzy blobs and blits in there. These guys are located about 30 million light years away from us. These guys here, these little ones that you see interspersed, are about 300 million to 500 million light years away from us. So this is what you have in your nighttime sky. And this is what you have to deal with. This is the view of the northern neck from space. That's Philly, Baltimore, Washington, Fredericksburg, Richmond, Tidewater. There's Kilmarnock. So all the pictures, all the deep sky pictures that you saw, I took from right here. So this is a rather, to me, sobering image, because even out here, you get out here, that's Interstate 81 out there, that's Leesburg. It's very hard to find places to go to now where you can actually see a dark sky. You are very fortunate in that this is one of those places. So it's one of the things that's very tempting for me to eventually retire down here. Hopefully the sky will be as good as it is when that happens as it is now. That said, there are things that we can all do to help maintain the sky the way it is. So I'm going to throw a few slides up here from one of the organizations that I belong to, the International Dark Sky Association, to give you an idea of really how easy it is to make sure that dark skies can be preserved. So we want to talk a little bit about what we call light pollution. So this is a view out over LA from up where the Mount Wilson Observatory is in California. They put Mount Wilson where it was because in 1910, this wasn't there. LA was basically a little village. But this is the way it is now. So there are a number of components to light pollution that are incorporated into this picture. The first of those is what we call sky glow. And you saw that in some of the pictures that I showed of the Milky Way, where you can see the glow along the horizon, that sort of thing. That is light that is scattered up into the sky from street lights, other lights, outdoor lighting that is just not properly designed. Then there's glare. If you can see the light from a street light fixture, especially the older ones, the high pressure sodium and the mercury vapor ones, the light that comes from those is from a very, very bright, very, very small electric arc. And they dazzle your eyes. It's like looking at someone coming in the other direction on Route 3 in the middle of the night with their high beams on. You know, takes you 2 or 3 minutes afterwards to kind of go, whoa, get your light back, or get your night vision back. And then there's what's called light trespass. Light trespass is when someone has a light that lights up your place when you don't necessarily want it to. These are the 3 components of light pollution. The first thing that one needs to do is educate people about this and basically say that there are viable solutions for it. A very popular myth that we have, so this is $3 to $7 billion of essentially your tax dollars at work, because this is all funded from municipal taxes and that sort of thing. Between $3 to $7 billion a year, and it's probably closer to 7 now, is spent on lighting up the bellies of airplanes and migratory birds. And that translates to 21 million tons of CO2 burned by power plants to supply that energy to light up those lamps that light up the bellies of airplanes and migratory birds. And there's a popular myth that bright light is better light. Now, you can go to Walmart and you can go and buy what is called a security light, quote unquote. This is typically a 175 watt mercury vapor lamp in a fixture that basically blows light out all over an area, and about half the light that comes out of that goes up into the sky. But once again, the light comes from a very bright pinpoint source of light. It's very dazzling and it's very bright. So if you're taking the trash out and you have one of these in your backyard, your eye is going to look at that light, first of all, because we tend to be attracted to that sort of thing. And your pupils are going to dilate and you're not going to have any night vision. So if there is a trash panda out there that wants the goodies in your trash bag, you're not going to see it. But if you have a light that is more diffuse or shielded so that you're not looking directly at that bright fixture, all of a sudden you have a much better sense of your area. And you can chase off that raccoon before he dives into your trash can.
Buy a BB gun.
Well, that works too. I use those on street lights, but This is an astonishing statistic. Planet-wide, 2 out of 10 people have seen the Milky Way. 99% of the U.S. and Europe live under light-polluted skies. You are in that 1% here. So basically, what do you do about this? The simple solution is when you think about lighting outdoor spaces, don't think in terms of brightness covering a large area. Think in terms of putting light where it needs to be. Now, as we were coming in here this afternoon, I pointed out that, and Ernie tells me that they're actually going to fix this, so hopefully that will be the case. But right out here in the parking lot of the library, we have an example of bad lighting. And it is a fixture that is called the Washington Globe because they're all over Washington, D.C. These are what I have to live with. And if you look at that fixture, you'll see that it's a long pole, and on top there's a big lamp, big light. If you turn that on at night, about 90% of the energy is going up into the sky. And the light that comes down to light up the ground is blocked by the base that the lamp is standing on, so you have a dark area around the base of the lamp where it's not doing anybody any good. The reason that those exist, and the folks at DDOT in DC told me this, is, oh, they look so nice in the daytime. Okay. Right across the street where the playground is over there in that little park, there are very nice looking street lights. But if you look at them, you'll see that they have large shields, and you can't actually see the lamp inside the light. That's good lighting. So come out here sometime at night, look at these lights, look at those lights, and there's the difference. There's the solution right there. So you've already got that incorporated. The other thing that's important is the color temperature of lights. We now know that blue light, which emulates sunlight, affects production of melatonin. So if you like to sleep at night and you got blue light shining in your window, or you have blue on your computer screens or whatnot, a lot of these phones now have a feature called nighttime, where it changes the color temperature of the display from a blue one to a amber one, or a more amber one. That's so that your melatonin cycle will not be interrupted. Most modern lighting fixtures that are being produced today for outdoors are flat panel light emitting diodes. And they come in a variety of color temperatures. So if there is ever a discussion down here in your local government about replacing old street lights with LEDs, which are, by the way, much more efficient than the current ones that we have, make sure that they have lamps that are less than 3000 K down in this part here. The other practical reason for that is that when you go outside in the middle of the day and you look up at the sky, what color is it? Blue. It's blue because our atmosphere preferentially scatters blue light. So if you have lights that are over here in the blue part of the spectrum at night, the atmosphere is going to scatter more of that light, and the sky is going to be brighter. Over here, not so much. Where to find this? You can go to Walmart. I have been to Walmart down here, and I have looked on the shelves that they have, and you can find outdoor lighting systems that have the IDA seal of approval. This is better than the Good Housekeeping seal of approval, as far as I'm concerned. But the International Dark Sky Association is a great resource to find more information about this. It's very accessible. You don't need to be an astronomer or a PhD physicist or anything like that. And they have a lot of very good points that they can make that you can bring up with your local authorities to make sure that you can preserve your nighttime sky. So, together we can save the dazzling night skies of the northern net, support the International Dark Sky Association, www.darksky.org. And on a final note, the International Dark Sky Association designates areas as dark sky locations. Virginia has more dark sky parks in its state park system than any other state in the country. They recently designated Sky Meadows State Park out near Paris, Virginia, as an international dark sky site. And I can tell you from years and years of experience that the skies that we have here at Belle Isle are much darker than what they have at Sky Meadows. Belle Isle has attempted on a couple of occasions to get this designation. Katie, the park ranger over there, has worked with some people, but I think a lot of them moved away. But if there is interest in preserving dark skies, a local advocate who lives down here would be a very desirable person to work with Katie to see this through. I would love to do it, but I don't get down here often enough, at least at this point in time. But it's something that can be done by local volunteer effort. Get that place designated as a dark sky site, and that will actually invoke state regulations on the immediate lighting in the vicinity of it. So that is something to look into. So that is what I have for today. If anyone has any questions, I would be delighted to try to answer them. Sorry about that.
Dark sky.
There we go. This tall guy in the back.
Yeah, can you talk about dusk to dawn lighting and architectural lighting?
Yeah, so in all cases, dusk to dawn lighting, those are what we would call the security lights, the glare bombs. If you want to have outdoor dusk to dawn lighting, you can get wall pack lighting that has full cutoff fixtures and LED panels. It will give you a much more gentle light than the glare bomb will, and it won't shine up into your neighbor's window. So that's one solution. The other solution is to have lights that are on motion sensors. Now around here that might be a little bit dicey because you've got all kinds of critters that are wandering through your yard at night and everything. They'd set it off every 30 seconds. But that is another solution. What was the other part of your question?
Architectural lighting.
Architectural lighting, same thing. You can work with architects now. A good architect will work with the Illuminating Society of America, which are the engineers that design lighting and that sort of thing. And you can work with them to incorporate lighting that is good, that goes down onto the ground. We actually did a renovation in our house in Alexandria a couple of years ago, and the original lights that they put to light up the steps going up to the front door were lights that were down in the pavement and shining up. And when I first saw those on the drawings, I said, no. How about you get little lights that are on the top of the pillars and shine down? And the architect turned to my wife and said, what's the deal with that? Why is it, and she said, he's an astronomer. We do that. But if you are doing a renovation or planning a new construction or anything like that, there are a lot of resources on the IDA website that will allow you, or that will give you suggestions and links to manufacturers of all kinds of lighting fixtures that you can incorporate for just about any use, and they're all IDA friendly.
I appreciate your comment about the dark skies approach there. I never knew any organization existed that you could apply a little bit of pressure to help.
Well, the organization started back in the 1980s when the city of Tucson was getting ready to change all of their lighting fixtures. And there was an astronomer at Kitt Peak National Observatory, which is about 60 miles west of Tucson. And he was upset that the astronomers weren't consulted in the kind of lighting that they were going to put in. So he formed this organization, and they began advocating locally in the Tucson area. They ultimately got the city to change their lighting plan and to install what were, in those days, low-pressure sodium lamps, which are basically like big fluorescent lamps instead of bright, high-pressure sodium, which are very bright glare bombs. So he got the city to retrofit all of their street lights, and at the time it was about 25,000 street lights, with a combination of low-pressure sodium interspersed with full cutoff mercury vapor fixtures to add a little color balance. Now, by putting them in fixtures that put the light on the ground, they could use less wattage in the lights because less light was going up into the sky. So the cost to renovate all those streetlights in the city of Tucson paid for itself in energy savings in 3 years. And the municipal lighting bill went down by to about 1/3 of what it was beforehand. So all of a sudden people in Tucson had lights and they didn't cost as much. What's wrong with that picture? So it can be done. And we've done the same thing now. We have a dark sky site outside of Flagstaff, Arizona. We work very closely with the city to maintain their dark sky structure as well. Yes, sir.
Can you get a tour of the Naval Observatory now? Are they still down?
Unfortunately, public tours of the Naval Observatory have been suspended more or less permanently. Sad to report, but the reason for that has nothing to do with the fact that the vice president's attended on the grounds or any of that stuff. It's really the mission of the observatory. And I don't know if any of you were here 2 years ago when I gave my talk on the observatory, but the mission of the observatory, the Navy suddenly wised up to the idea that this is a strategic resource. And they don't want anybody kind of wandering around there unescorted. And we frankly don't have enough people to escort a public tour anymore.
Does that mean you could get a private tour?
If you know somebody, not necessarily me, I am in the process of, of course now we had COVID and everything, I am in the process of trying to reinstate certain tours for certain special interest groups, government, mostly it's government and military people, but there are other organizations. One of the best tours that I ever gave there was for a group of farmers from Iowa. What the heck would a bunch of farmers from Iowa want to do? Why would they want to come see the Naval Observatory? Well, it's because the Naval Observatory is the timescale reference for the global positioning system. And farming today uses GPS. They have computers in their combines, and they have precise data on where they are. They also tap into databases that map the soil of their land, the contours of their land, the drainage and everything. They plug all this stuff into a computer in the combine, and they sit back, and the combine goes and it does its thing, puts the right seeds in the right soil and the right water conditions and so on and so forth, and it does this all seamlessly. They wanted to see where the time for GPS started. So
Maybe at the end I can tell you what my specialty is.
all right, okay. Yes, sir.
What would be a recommended camera for an amateur astronomer?
Almost any digital single-lens reflex camera will do. Most of these images that I took or that I showed you were taken with a very low-end Canon DSLR, EOS SL2. The camera body sells for about $400. And a tripod. Tripod is important too. So the lens, it's the lens that comes with the camera. Oh, no. That big white thing is my telescope. So, no, That's what we would call an accessory. But for basic skyscapes and that sort of thing, a good DSLR, they are very sensitive. And no, I used to. Now I have a dedicated camera for astrophotography, but a lot of the images that were there I took with my older DSLR before I got the new one. So it's possible, yeah. And you know, it's something that people don't necessarily think about, but you go out with a wide-angle lens, put it on a tripod, take an exposure for 30 seconds at ISO 6400, and you'll get a beautiful shot of the Milky Way. Just like that. No fuss, no muss.
Okay, one more question, please.
Yes, sir.
What kind of software do you use to process the imagery?
Most of the software that I use is actually freeware. It depends on the application, but for the digital stacking of my dark sky images, there is a software package called Deep Sky Stacker, and that generates a file that I then use another freeware image processing package called the GIMP, which is basically like Adobe Photoshop, but it doesn't cost you $700. It's free. It's my kind of price. And I do my post-processing with that.
Thank you, Jeff. That was wonderful. Appreciate it. Jeff will stick around for a while if anybody has any individual questions. In the meantime, thank you all for coming today. We have refreshments in the back. And don't forget, next week, April 3rd, we have our next Sundays at 2 session with Zeno Gamble from the Blessing Project. He's going to talk about empowering small communities and forgotten people, which has to do with the refugee situation, which is pretty current today. So, and then 3 additional sessions after that. If you haven't picked up one of these green flyers, feel free to do so at the table. Thank you all for coming.